what's AI in general? So let's start reading, from principles. Like this, what Wikipedia says that it's like the theory and development of computer system able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. So what we usually do for games is a bit different. That is, the artificial intelligence, everything that it's used to generate intelligent behaviors primarily in non-player characters, often simulating human-like intelligence. So if we have a game, what we want is that the player or whoever plays with the game perceives some intelligence. How we do it is less important than what we do. We want that the final experience is perceiving intelligence, thinking that something is smart. Hello. But then,
Use a microphone, awesome.
I'm just like, they call me Madonna already. So just a little recap for where just arrived. So what's AI? It's something that makes the perceiving intelligence somehow. For games is it's mostly used for NPC characters mostly, but we have lots of artificial intelligence algorithm or techniques that can be used for other activities. And this is what it's AI for us. That is, as I said, everything that allows the player to have the feeling of intelligence when playing against the game. Now, this can be little tricks. This can be, some kind of strange setup that you do in the level. That is what the player perceives as smart, and that is the most important part. So let's say we have an NPC, a human-like character. So this is just composed from lots of different elements that makes the player perceiving him smart or intelligence. So we have perception, because the character needs to perceive what is in the world, what's happening around, who is interested in. Then we have navigation, that is all the information basically in the level that allows a character to move from one point A to point B, or how to understand, for example, if some areas are reachable, if some areas cannot be reached, how to even analyze the space. So, for example, where to hide, or where is the best position where to shoot at. And this is information that is in the world. Then we have movement. So, like once you know how to reach a point, you need to move to that point. That means how you move is really dependent from your character. And this is also why we have like a system to be able to analyze a path and decide how to move the character around. Behaviors, the character of course needs to behave somehow and needs to take some decision. So when we talk about behaviors, we're basically talking about the decision making. So when we decide what the character should do, or when he decides what he wants to do, that is what we call behavior. In some cases, you will hear talking about brain, but anyway, for us the concept is behavior. Then we have readability, that is the main concept of telling the player what's happening and now what happened, because like anything that happens behind the scene doesn't make any sense, so it's not really important for the player if he cannot read what it is. So we always say like what doesn't, it's not on screen, it never happened. If you don't see it, it never happened. And then we have the word interaction. So how the character interact with things in the world. For example, as we said before, we can know maybe where the cover positions are, but how do we retrieve them? How do we know where is the best cover spot where to go? So that is other stuff that we need to understand. Or how do we jump around the world? How do we pass under a little door, or how do we perform some special actions? Let's start with perception. So what's perception right now in the game? So we have different projects, different games. What I will do, I will just show first for each element where it's in the code. So for technical reasons, you know where it is. In our case, CRYENGINE system, we have a folder called perception. And we have different things inside. So we have target selection, perception manager, vision map, global perception scale handler. So there are different elements that belongs to the perception concept. So perception is everything that is related to just detect things, or see things, or hear things, or some kind of sixth sense that you perceive that is something happening, but you cannot really express as a sense. Right now we have two systems, so let's not talk about Hunt, because Hunt is a bit special. He has his own implementation, and also Rise had his own implementation. Let's talk about the Crysis games, like since Far Cry time, and Crysis 1, Crysis 2, Crysis 3, and I think All Warface uses something connected to this. So in Crysis 3, what we had was basically there were two different systems. That was the perception manager and the target selection. This for historical reason. There was stuff from Crysis 2 that was using the perception manager, and then the Crysis 2 as well, it was implementing the target selection, but it was just a bit mixed up to not change some stuff. And so we basically had two different systems talking each other and being there at the same time. It's not really ideal, but that's what it is. Both systems use, for the vision part, the vision map. So the vision map is a really simple concept. It's like you have a map of object that can be, that can see, it can be seen. And this is the difference between observable objects and observer objects. So each observer has an eye position. So it tells, okay, I can see, and this is where I can see. And there are parameters that you can pass. So you can say, for example, okay, this guy can see this type of object or this type of actions, different elements. What happens in the vision map is that you can register, you can say I can be seen by other people, or I want to look at around and see if I see something interesting. And the vision map takes care of sending raycasts around the world and detect what is visible and what's not. And if you have like collision, something is going to hide, or if first is visible and is not visible anymore. The vision map does this for all of you without you taking care of that. So the only thing you need to do is you need to configure yourself. And you can configure this through some parameters that can be specific from the observable and the observer. In this case, the observer, for example, has the eye position, eye direction, so where the guy is looking at. Some information like which entity ID is connected to. If you have some raycast flags, for example, if you have a special X-ray vision, maybe you want to say that you can see through objects, and you can pass the physics parameters to the raycast, saying like, okay, don't hit these objects. Or for example, one thing that also Luciano was working on was more like, for example, soft cover. You can say if you want to consider soft cover or not. Then you have type mask that are some type of object. This is all flags that you can specify. So they don't make much sense from the vision map point of view. They're just flags, but they have a special meaning for you. It could be, for example, in this case, we have still a faction to observe mask. So this concept of faction directly in the vision map, even if it could be generalized a bit more. And then we have user data that you can pass and have some stuff that you get back when you need, for example, to retrieve which object it is, or some special parameters. And you have callbacks. But this tells you when something is visible, for example, something is not visible. And then you have what the observable objects are, that you can say, for example, which position they are, or if you have some, as well, type, affection, you can set the callback, which entity ID you are. And basically what happens is you tell the vision map when something changed. In this case, for example, if you move, you update your position. The vision map knows, for example, if an object is visible and never updates, it knows that that one is just static, and it's not gonna, if you as a player, you don't move, for example, you're an observer, then it's not gonna request again if that object is visible. It already knows that it's visible. So, it's gonna optimize all of this. Something changed, you have some special parameters that know what is changing, and it knows how to update things and who needs to update. So if the player only moves and he rotates, he knows that the rotation of the eye is happening, and stuff like this. What is good is it updates only when needed, as I said, and the raycast requests are put into a H priority queue. That means that you don't care like how to send all these requests. Something eventually is gonna be served. So there is no deadlocks for requests. It's never gonna happen that somebody send a request that is low priority, and this is never gonna be served. So you're always gonna wait, or you never see things. Eventually, you will always see things, and you can configure these things. You shipped already several titles. And as far as I can tell, there is not really something bad that would prevent you to use it. I think it's a really cool system. You should use it, even another project. And it's really isolated. So there is nothing really connected to the old code. It's actually kind of abstract and really general. It can be used from, any game code. And it's really, really simple to use. Any question about Vision Map?
How do you specify something like if we said some type of AI can see through walls? Mm-hmm. There was a way to specify that.
So basically, right now, lots of these properties are in the Lua. So you can say, these are the properties that you can specify. In this case, I think the registration happened through the creation of the AI object when you pass the parameters from the entity in the Lua script. But at the end of the day, it's just a call when you say, I think, register observable, right? Something like this, and then you pass the observer params. So you can choose, like, if you have, like, for example, in AND, We have schematic. Schematic usually is responsible for registering the observable and observer parameters. So, and then usually the designer can decide, what are these flags. So we can expose the flags that we want to the designer.
Okay.
Right now it's a bit more tricky because you need to know the parameters. You need to, put it into Lua, so you need to have this data. But before was a lot controlled by the programmer, so you could look at the code and see which parameters you need and stuff like this.
My experience, I introduced this request flags thing, but if you want to tell the vision map of the observer params that you can set to the walls, so basically ignoring the raycasts, I don't think it's still possible yet. So the raycast is always happening and it will always stop.
But in that case, why you use this? Because this is the point of this system, is to make recasts, like to check visibility.
No, but you can.
I understand, what you could.
I think it's just not exposed to the Lua.
There's the field of view, for example.
Yeah, but you can, for that again, it's just the flags for physics, because this is so.
Yeah, no, what I mean, the flags for physics, they don't quite work yet. So
but do you mean they don't work in Lua? Because in code you can pass just whatever you want. So it can be that maybe not everything is exposed to Lua as a flag, but that is fine. But in code you can just pass whatever flag you want.
Yeah, it's not very important, just a technical detail. I try to make the AI see through, making a raycast which was bogus, it didn't work out.
Okay, but we need to see what it is.
Yeah.
I think there is
Because
nothing
in fact,
really
we
preventing that.
thought that this case should be handled differently, not shoot the raycast.
So if the object is basically flagged, in your case, like a soft cover, it needs to be properly flagged from the asset side, which then goes into the physics, and then the physics.
I don't think there is anything basically preventing you to do it. I think it can be that there are some stuff that is not exposed, and then of course it depends. Lots of stuff is exposed in relation to what we needed in the past. If you need something new, it can be that you need to expose some other flags to the I system or to the game code. Yeah, that could be. But the raycast is just a normal raycast, so it could be that some stuff is hard-coded right now. This could be, some basic default flags that we always wanted in the past, and we can maybe not make that hard-coded. But these are really like little details. Like at the end of the day, you just pass through the physics. You just give the raycast or whatever parameters you pass. Yeah.
The system is only based on visual response?
No. There's more stuff. So we'll see. Like this is the perception manager. Basically, this is the old, let's say, perception system that we had, and this was basically able to detect more stuff like sound or incoming stimulus you could set up, and basically it handles this type of stimuli. For example, we have these types: so sound, collision, explosion, bullet widths, bullet teeth, grenade blast. The problem here was that these were really hard-coded. So you had this enum set, you could do only that. And then there were some specific subtypes that was not really clear in the code which one could have subtypes. So you could pass this flag, but maybe for some types it didn't make any sense. So in this case, for example, the sound had these other subtypes like generic, collision, collision loud, movement loud, weapon, explosion, and last. And some of these were also used into some others, like maybe the collision loud and collision were also used in collision, but it was not really clear. And also like the grenade had special ones, so thrown, collision, flashbang, smoke, and last, but it was not really extensible. And also the big problem was lots of game code concepts were inside the I system. So what happened was, you can debug the debug perception manager with that CBAR. It's basically you see this, that is not really clear what it is. This doesn't give you really enough, so you need to debug also the different stimuli and see where they come from. But this system was a bit, cluttered as well. So what happened is that during Crisis 2 was made the target track manager. That when you debug, basically you can debug per agent. So you need to specify the name of the agent. You see this little box as well. This is time, and this is basically the inputs of the value of that, perception that he has for the specific things. But this is the thing, the debug draw also here is not really clear, so it's really hard to debug. And here you see all the different stimuli that arrive. Maybe we can just move this one here. So you see, in this case, we are getting a bullet train stimulus, visual primary, sound, movement, loud. What it was basically increasing this was custom. Basically, was able to be customized in a bit easier way. So the target track is customized into this file, that is the iTarget stimulus config. And it allows you to basically create some stimuli as a string. So you can say like, okay, I have a bullet train, but it's just like a string name. So it's not really anything hard-coded in the I system. And then what that stimulus is, you will specify into this XML file. You can say, okay, for this stimulus, when it arrives, I get a boost on the value of the perception of this amount, and this value stays for a certain amount of seconds, and then it decays. Basically, the way you were doing it is from the game code, you would call handle stimulus event in range or handle stimulus event for agent. So you would say what is the target of that stimulus, the stimulus name, and then some event info. What is strange here is that it's not really clear what means target and agent, and I had lots of problems in the best to detect because sometimes one means the one that actually is doing the stimulus, sometimes is what he should receive it. Is a bit weird. So in this case, I think, if I'm not mistaken, this one is actually the target of the stimulus. So it means who's making the stimulus, and this one, if I'm not wrong, and this one is the agent in which you want to send specifically that stimulus. So one is in a range event, and it says like, okay, this guy made this stimulus, maybe like a footstep sound, and with this name and these parameters, and it's hearable or it's perceivable, let's say, into this radius. And then you have this other one that you want to send exactly one stimulus to some guy. It's like maybe the guy had a sixth sense about hearing somebody in the other room. He felt that there was something happening, and then he goes there. You can track it with this CVAR. You can debug it, and basically what happens is you can customize these parameters. So for the stimulus event, you can say which position it is, which threat target level has, and this type of stimulus. So even this one. He had some hard-coded values as well, so he had generic, visual, sound, and bullet train, because some stuff was still handled specifically in the game code, in the I code, in a certain way. But basically, what was happening was that lots of stimulus were generic. It was like generic stimulus, like the ripple of the water are there, And some other stuff is the target threat. So the problem we had as well with this one was like, which one is the real one, and how much you can customize this, because if the character before was getting an aggressive stimulus, then that was the most important thing. And imagine at that point you have a certain level of your knowledge of your target, that is, I know that there is somebody aggressive around. Then when you wanted to tell him that there was something interesting happening as well, the guy was just completely ignoring that, because the target track was saying like, I don't care, I have already something more important, this I don't care. And there was no way for you to say, okay, but I want to know that if it happens. I wanted to know if an object fell from the table in the other room and I heard that. Even if it's not really a threatening sound, it may be related to that, but you don't know anymore. So the big problem with all this system was both the target track and the perception. Okay, let's first go into how you can customize the stimuli. So in this case, for example, you see that you have the visual primary, visual secondary. First of all, it's like, what do they mean, right? It's a bit weird. What is primary visual and secondary visual? And you have lots of parameters, like, if it's on style only, so if you only see your style things, what is the peak? And also these things that we were always trying to understand, is like, what's a good value? It's like 5 is a good value, 6, 15, nobody really knows. And at the end, what happens is that this file was really tweaked for Crysis 2, and then we didn't really change it anymore, because it's really hard to understand, like, okay, how much is that? What does it mean in the attack if it's 2 or if it's 2.5? How much does he influence the gameplay? You will never change this value. So things were really going into a complex environment, and it was really hard to tweak it. And at the end, nobody really wanted to touch it anymore. So the good part of both systems is that they ship several titles that are there. They work. If you don't want to do another Crysis game, yeah, it's gonna be the same, kind of experience as before. They're already there and they work, and they have lots of configuration. It's cool, right? But it's also bad. You have lots of configuration. It's not that cool, because when it's too much, you don't know anymore how to touch it. There are too many concepts inside the system that should be in the game code, and it's really hard to customize what you want to do if there are some special things. Like, as I said, like, if you want to get, what we had to do for Crysis 3 is we had to, from the external point of view, we had to tell the target track that we wanted to lower the threat level after a while. So the behavior knew it was doing something against a threat, but from the target track perception, he was thinking it was not anymore aggressive, but maybe it was just interesting. So we could still get that values back. And it's over-engineered. It's just too complex for what it should do. We had lots of discussion about what it could happen here, how it would be a good way of doing perception. I think we should keep it easy, first of all. It should be a system that just keeps track of what happens, and then it's up to the behavior to request what do they want to know. So if the behavior wants to know what is the last interesting thing that happened, then the behavior should ask. Or the system can tell the behavior, it can tell like, hey, I heard like an object falling. Then it's up to me if I'm interested or not, but I should get that information. I should not be, nobody else should filter information for me. So yeah, another problem is that none of these systems really support MP. They just do it, do stuff. If you put multiple players, yeah, it works. It doesn't crash. Somehow it gives you one player, somehow it gives you another one. But there's no real way of saying like, oh, there are 4 people, against you. How do we handle these 4 people? What is the most threatening one? What if they surround me? Which one should I target? Should I target always the same one, or should I change because the other one come close to me? This is not really something that works. And this is the same way when we see lots of tests, for example, even in the past, in Crysis 3, the first test, or also our tests sometimes, and we're just putting like 2 factions fighting each other. And that is like, yeah, it works. 2 factions is just shooting. But then they do really weird things. Sometimes one guy is shooting at you and other faction people are here, they just don't care and continue to shoot at there, or I switch and the guy is just throwing a grenade, but I don't care at that point. Kind of these things. It happens lots of stuff that you cannot control, and you just see things happening and it feels it kind of works. So don't always like fall into the trick of thinking that something works just because something is happening, but try to understand really well with the eye, what do you want to achieve? What is the key element that you want to have there as experience, and then you try to model that. Because if you don't model what you want to have, then you end up into something that kind of works, but then you cannot tweak to what you want later on. You won't have time anymore later. This is a really key part. You should not shove something inside the eye brain from the outside. Like the eye should not have people or other systems just changing what they're doing all the time, because they will just lose context of what they're doing. And it's just gonna look really bad. So what we saw like from Crysis 2 time, there was the behavior that was switching a lot, and the target track was putting you the target, and it was also removing the target. So there were checks everywhere. It's like, if I have a target, I shoot. Now you were shooting, going into the car, say, oh, if I have a target. It's like, yeah, but you just knew. You had a target before. But the problem was, this system could remove your target at any moment. And then you had to check all the time. And this just makes so hard to create a behavior that does all these checks, and is consistent, and it's safe, that at the end of the day, this flexibility is actually giving you many more problems later on. Any question so far? Something is unclear. So the perception is a bit, something we already have, but it's something we should work on. So I think with Hunt right now, Mario is working on some other stuff on the perception, and I guess just different. And basically, unfortunately, we don't have an out-of-the-box solution right now that we can say that we are happy with, and we can continue to use. Yes, we can continue to use this one, but it's not really the ideal thing. So
you said like some things that you just shouldn't put in, or like you should just put directly in code.
Mm-hmm.
But then that gets buried inside the game's code. But then when it comes back out to the SDK, we can't technically have that game code associated with that game, and then we're lacking a massive portion of what should be included. Fair enough, but it should be in our code and then somehow.
Yes, so that is the big problem of having a proper split, because of course what is good from Crysis 2 was that when we sold the engine, of course the engine was kind of working for a shooter that didn't look really like Crysis, right? Anything else, well, it was not that easy to tweak. And this is why lots of licensees at the end, they didn't use our AI system, because at the end of the day it's so tied to how the AI works for Crysis, then people were also a bit afraid to use it for other things, right? So the key is, of course, there is some stuff that if we make really nice systems that are separated, then you will have to implement in the game code. That's true. But that will allow you to customize really what is the type of game code that you want. So if the SDK game code is really based on, for example, a test map that is a shooter, then of course we can continue to keep that part working. And I think with the structure that now is with the engine, now we have still the game SDK running in all the project in main, every time we do a change, we can test something. So if we have a good test case there, if we add a new system, we can always keep the game SDK running, and that will help to have the example. And also the example will be a bit more clean, so people could also. So it's a bit of effort, yes, for sure. It's not something come for free, but it's something that gives you a better quality later on. So it's just a matter of balancing. Another question?
Did you have any opportunity to have a look at the stimulus system from 1.2?
Oh, yes, but it was basically a lot into this direction. So it was different, but it was at the end really similar. So there were 1 million Actually, I think the base was really the target track or something like that. But it had like this XML file that was huge, 1 million different stimuli you had to add, and sending some. The only thing you basically were saying, this stimulus send you this signal. But it was really, really complicated to understand what happened. And actually, there were already like some really hard time to tweak some specific behavior into modes. So it's a bit tricky. Also, I think the perception is also kind of a bit more tied to what the game is to really understand what you want. But there are some stuff. I'm of the opinion that some stuff can be as a service in a system, but it needs to be really clear what it is. It should not be too much. Lots of stuff should still be in the game code because the perception is really tied to the game code, to what the game is. Navigation, I think lots of you already know a bit on navigation because it's actually the one where even level designer or game designer have a bit more to deal with, just setting up the environment or making a test or creating where to navigate. So in this case, navigation is inside the I system, navigation folder. You have different structure, data structs, M&M, navigation system, Pathfinder. You have some extra stuff there that not everything is really needed. Some stuff is all navigation code. So the important part is navigation system. Navigation system is basically the container of all the navigation stuff. So it contains lots of things. In this case, I just put the most important part. So one is the agent type. So the agents that are allowed to navigate in the world are contained in the navigation system, are registered there through this navigation XML file that is in the I system in Scripts AI. And basically here there are all the concept of the agent. So like how big is the agent? How much is the slope that it can climb? How large is it? How it can fit around? Which type of voxel do you want to use for that agent to voxelize the word? That's all there. Then you have what actually makes the navigation system working. So like I see lots of people getting a bit confused through saying the words navigation system and M&M and grid and mesh and what is mesh, what is navigation system, stuff like this. So the meshes are just contained in the navigation system. So navigation system has a big, map of meshes per agent type. So each agent has its own mesh, and basically you can say, I'm a medium-sized character. This is my mesh. So it's a big mesh that contains lots of triangles and data to make me able to navigate. Basically, each mesh is contained into this navigation area. When you draw in the map a navigation area object, that's one mesh. So I think a bit of confusion comes from the fact that the mesh in rendering is a bit different from what we call mesh, because it's not really a connected, triangles. It's set that the triangles connected, but it's more like everything that is connected into this navigation area object is one mesh. So then, this triangle can be disconnected, can be partially connected or all connected. It doesn't matter too much for us. And you see, like you have these different, inside the mesh map, you have different IDs because you have, for each agent, you have a set of possible mesh. So if you have 3 different navigation areas, you have 3 different meshes for the agent that are separated. And right now, you cannot navigate from one to another. Then you have the tile task queue and the tile task results. So what happens is, when something changes in the world, so when you move an object, the object is basically saying, the object contains this bounding box. And when I move it, basically I check all the tiles that are in this bounding box that are affected by that. And I'm just queuing, saying like, hey, something changed here. Just make a new calculation and check what is changed on the navigation side, because some physical object is moved. And what happens is, so you put in the queue the request of the task, and then the tasks are processed in a separate thread, and then when they finish, they put the result into the list of the task results, and these one then are applied in the main thread. So basically what happens is you have a multiple task list that can be processed at the same time, then they send back the result, and then the results are connected to each other. So the task operation is related to the tile. So you have one tile. It's also a bit confusing maybe for you guys because tile is not the same meaning as what hunt has. So basically, I will show you how, it's the concept of tiles in navigation mesh in a moment. Basically, this is the navigation mesh, what the navigation mesh actually contains. There is a mesh grid. So one mesh itself is what is contained in this navigation volume. And it contains the actual grid. The actual grid is the actual concept with the triangles, the links, that are connected to each other, and they tell you how to move. Then you have the navigation agent type ID, so to who you are related to. So if you are for navigation mesh for a medium-sized character or not. Then you have the volume ID you are belonging to, the exclusion volume, if there is any, that is just cutting off some parts that you don't need. And then the name and the version is like more the bug stuff. So this is basically the concept of how the navigation mesh is. So you have a tile container. So basically inside the word you see different tiles. Just like, the word just split into tiles, just blocks. They can be different sizes. Right now we use cubic size, so it's like 888 or 161616. Not much more. These are just like adjacent tile. Even if they don't contain anything, these tile exists. They're just a portion of the space. Inside this tile, there can be triangle, because if there are physical object where you can walk in, the navigation system is going to create some triangles on top of that. And each triangle is going to be connected with other triangles, with some links, saying this edge here is connected to this edge here is connected to this edge here is connected to this edge. And you just know how inside one tile, one triangle is connected to the other one. So you can say, which one are the triangles? I'm in this triangle 1. Which other triangles are close to me? You just don't know. You cannot ask directly a question. You can say, which connection do I have? I have 3 connections. Okay, the first one goes to triangle 2. The second one goes to triangle 3, and the third goes to triangle 4. So this is what you know. And you can just move from one triangle to another. Then you have some other links that are links between tiles. This sometimes you get acknowledged saying, okay, I have a link, and this link is not internal in the tile, but it's in another tile. And then what you need to check is, from your link, you check which one is the neighbor tile that you get, and you can access the triangle in that tile. And then you have this special link that I throw in white. These are a smart object link or off-grid link. That means these triangles are not really adjacent, and they don't have really a connection between them. But the level designer decided to connect them, maybe from a jump, or maybe I have a special teleport node that just says that I can start from here and I can teleport directly over there. And this is what the special link is. The navigation system doesn't know how this special link is implemented. It just knows there is one special link, and it knows to who ask which type of link it is. Each tile is contained inside a tile container. So this is actually the structure of the code, how it is. So the tile just knows I have an array of triangles, an array of links, an array of vertices, and some binding volume 3 that is not used. It was used as a test from Marcio to just access directly some triangle when it was just to test some stuff, but we could even cut it. And then you have X, Y, and Z. These are the ID in the space where you are. So you have a triangle that is like the third triangle on the X side and the Y side. And knowing your size, you also know where you are actually in space, basically. This allows you to say, I have an object, physical object in this point, to which tile do I belong, which tile do I touch, and you can request a regeneration of that tiles. Basically, you have this array, so things are really laid down in memory really easy, and you can just access them one by one. It's a bit faster. You can just access and queue, directly access to other triangles.
Are these tiles, the amount of tiles and the size of the tiles, are they defined based on the size of the height map of the level, or are they hard-coded?
Basically they exist only when something is inside them, but virtually it's just depending on the size of your map. So if you have one map of 1 kilometer, like 1 kilometer, then you have certain amount of tiles that fill up this 1 kilometer. But in memory, you only have the one that actually are containing something.
Can triangles be part of 2 tiles, or are
No.
they?
No.
What happens if?
So usually what happens, since you have one tile, so what happens is you generate all the triangles in this tile, and then the generation is not really tied to that tile. So the bounding box of the tile is a bit bigger. when we do the voxelization. So we get maybe triangles that are a bit on the edge. And then we scale it down. We just cut it inside on the border. And when you generate the next tile, basically you have new triangles. So you have some triangles that are basically, we'll have one edge that is really similar or in common. And what happens is when you attach one tile, when you commit one tile to the navigation system, it evaluates what are the edges that are the same, and then you really attach them. So if you have one triangle, basically, one big area that is all workable, you will always have some edges that end on one triangle and start with a new.
So the tile B, if you like to have navigation on, so you write request I want dash the box and zip it across the thing. That's
yes,
the
that
tiles.
are the tiles. Yes. Yeah. Any other question?
It's one thing a bit technical. Just if we want to, create artificial links between triangles, like you specified, we say of course a smart object. Is there a way to create? I mean, how is the smart object? Is it like because it's one where you define exactly where is the start, where is the end? It's not scalable or anything.
So now,
for example, I was thinking about something we talked about today in the new project, like climbing a wall or something.
Yeah.
The wall can be any height, and I want the AI to be able to go from this point to that point, but not using the normal navigation, but a special action like climbing.
So the thing is, the smart object don't allow that. The thing that we use in ANT, for example, that is so the off-grid link. So there's one concept here. The wide link is not really a smart object. It's a smart object for crisis games, But this is just an external link. The navigation system really abstract this concept so everybody can extend it as you want. So it could be an area, it can be anything. In Hunt, we have these 2 points. They just connect. You can say which type they are. So in that case, you could make the level design would make the wall as high as it wants. Then you would just put one point and another point. They would just say this is a jump down or a ladder. And then it would just play the animation of the ladder. So basically, you will have to extend it in your game code to have this specific feature. Maybe it's something that we want as a general concept, but this is a different problem, right? So the Hunt custom links, for example, could be used, could be part of the AI system and extend what the smart object were. But the main concept is there's no really limitation from the navigation side. He doesn't care if it's bigger or lower. For him, he needs to know from which triangle you start and which triangle you end. Then how you handle that, it's up to you. So it will just tell you when he finds a path, it will tell you, okay, here you have a special link. And then it's up to you. You have it in the path, you have the information, how you handle it. It's not my problem anymore.
Is there any system that specifies there's a special action to navigate this link?
Yeah, we will see it after.
Okay.
Yeah.
I'm just going to say it's probably worth mentioning that something we inherited from in the Hunt code base is a system for procedurally generating all these links between navigation meshes as well. So you just give a set of metrics and say this is how high a character can jump and how far forward, and this is the type of obstacle they need, and then it just generates all the links for you so the designers don't have to manually place those things.
So we are still evaluating the code, but it's cool. It's a cool concept that we always wanted to have. On the other hand, whenever we asked the level designer if they wanted to automate that, it was always said, to us that it was the less of a problem somehow. Because lots of the time you can also embed into some archetype or whatever, a jump, and where you place that level. If you have a procedure generation, you could have a jump through the window, because Austin has both things. Has had a procedure generation of the links, and then he also had some stuff embedded into the kind of archetypes. So if you had a window, he was always putting this jump from the window, and you always knew that you could break through the window, jump over. So you can still combine these 2 things, and it's good to keep it, as much as possible, this flexibility, because it's not too hard to do the procedural part, and I think you can just save lots of time to the level designers. So I think it can be cool. The only thing is that you need to have a good way of making them able to tweak these values. Because if it's always generated automatically, then you may have some places where you don't want. It was similar to what UK did with cover. The cover was generating automatically through all the navigation. We had 1 million cover spots that we didn't want to use, and you didn't have a way to tweak it. So you need to balance this thing. And actually, I think the best is always talk with the level designer and ask what they want, and see where is their time spent, and how you can optimize that part.
Yeah, I don't know if you want to cover this afterwards, but is there any concept on setting costs on the links for heuristics?
So right now the cost for the smart so The special links have a cost on their own system.
Yep.
So they are asked which is their cost, and they will return.
Can they be user defined from the game code? So
The custom links, yes.
Is more expensive.
Yeah, the custom links can.
Okay.
So the custom links, basically each link can return their own way of calculating their cost. For example, if it's a ladder, maybe you want to put the length of the ladder, and it's depending on what it is. If it's a jump, or if it's a passing through fire, you want to say like, okay, this guy really doesn't care about passing through fire, and it's cool if he does. Actually, it's cheaper for him if he passes through the fire instead of passing in the normal path. Smart objects also have their cost. You can specify there, and it's just propagated through navigation system. The normal links you cannot, because that is just the Euclidean distance, and you will break a star if you would change
these
it.
weights are in the actual mesh, or can be modified in function of the archetype.
So the special links are not in the mesh, are in the system that implement the special links.
Yeah, but I mean, depending on who queries the path, might be different.
Why?
For example, let's say we have a guy that likes to, I don't know, it's in the gym and likes to climb ladders.
That's fine.
And another guy that wants to take the elevator.
Yes.
So the path for both will be different.
Yes,
because the
it
heuristic will
could be different. Yes.
Okay.
Because it's just when you request, you can say who requested that. I think it's already passed, so you can check for that specific agent what are the properties of that agent, if you can use it, and what is maybe their cost. I'm not sure actually if we pass that information to the get cost request, but we could extend it because we know who's the requester, so you can say this entity has requested you the cost for the ladder, just give me for this entity, and then the game code will know how to handle these parameters. Or in our case, it's the smart object, because the smart object have a concept that all the I objects that are passed are also smart objects, so you can basically match the state and say like, okay, this guy actually is allowed, or this guy is not allowed, and you will have different links for different agent combinations, so you will say different cost.
Can you do that like on area base? Like if you have like water, for instance, or whatever, you want water to have a high cost. Is there ways like flag it and then
So right now we had this concept of dangers that you could place. It's not really yet extendable as we would like to have, but we could say that is more expensive for some reason. And now we had in Crytek 3 we had the grenades, and we use some similar concept to Rise for the fire, just to say we adjust. But the problem is that code needs to be done properly. So I think we could do it. It's just not there yet. So it's not too complicated to add something like that. But the problem is sometimes the Pathfinder will only know, for example, if something is more dangerous, we'll try to not do it. And this is fine. So that one is kind of easy that you can do. You can register an area. You can say like this area for this radius has this increasing cost. If you want to really avoid that the path passed there for some special agent, then it's a bit more tricky, because it could be that you don't have any path at the end as a result, and maybe the only one that is passing through. In some case you want, some case you don't want. It's a bit trickier to change the pathfinder. Yeah.
Which I forgot. In the navigation, is there a way to tell an agent that like for example, managing the stance? Like, okay, the agent can walk through this pipe, but it has to crouch. So there is a link actually, but
that would be only through smart object or special object.
Okay.
So if you want to make a special case scenario in which he crouch and he pass through, right now it's only through a special animation that it needs to be uninterruptible and just go through.
In the same case scenario, let's say you're kind of traveling through air ducts, and they're not straight, and they're not fixed, so the animation can't be baked for that thing. Could we have an animation system, something that comes from the
easiest way
tells him he needs to use?
So the easiest way you could do something like this right now without changing any code is you need to make a special agent type that is the one that passes only through the pipe. You won't get a real path that passes through that, but you could say in the behavior that you want to use some pipe, then you can place some special agent and say, okay, there is an entry here. So you will enter there, and then from that on, you will change the stance, you will change its type, and then it will only navigate through the pipe till some areas around, and then you need to switch it back. So there is no really easy way for now, because you will need a completely different voxelization. You will need to match these two things, and we don't have it. It could be extended, something like this, but it's a bit more tricky, I would say.
Okay, so so you've got like 5 people standing roughly in the same middle part, all told to go to the same area. they'll all pretty much pick exactly the same path.
Yes.
Is there any way to make them say like, well, I'll go like slightly and take a smart object?
So Hunt tried to do it, and they failed because there is one big problem. It's like depends a lot on the topology. So the topology navigation mesh is much more influencing the path compared to the actual weight that you can put there or something. Because also the time you have one triangle that is just big and everybody wants to pass there, and it doesn't make much sense from the Pathfinder point of view, to be more expensive that one. Just that he needs to pass there, and he will pass from the center because for him it's the best path. So you should basically what you want to ask is like give me 5 different paths that are just not crossing each other. And that way you could create a specialized star that gives you not only one path but maybe multiple ones. So he knows in the meantime how it generates, but it's also a bit trickier. One thing that we always did was we had this concept on top that is the collision avoidance. So when they were walking, then the collision was trying to not make them hitting each other. It's not extremely good because they want to go somewhere, but another system switch their speed. The animation guys will not like that. Another case what we tried to do was to basically try. So with the collision avoidance as well, we're also trying to extend this concept with the weights, with the danger area, saying that basically where if you move a lot together, if you regenerate enough the path while you move, then if you tell that one guy is a kind of a danger for yourself, then you will try to wait a bit more the path at the beginning at least. So you will try to spread at the beginning the first part. Then even if later on you merge, since you regenerate, you will just not try to collide. The other thing is a lot depends on the behavior you want to do. If you tell 5 guys to go mostly on the same spot, yeah, they will probably collide each other. It's the same in real life mostly. If you just don't tell them what they want to do differently, then they will have some problems. So the idea is also to create your behaviors in a way which they also can handle that. We had, more analysis from the top. That usually what helped more. There is no really easy solution here to fix this problem.
Because another weird thing I found is like you say, we need to go up here, but this path they've pretty much all chosen would be via a smart object.
Yeah.
So only one person uses it once. All the other guys are sitting there like twiddling their
They will
thumbs.
wait.
Could they not like recalculate then to pick another
Yes.
smart object or
You-
just take
you-
another path?
You could. So if somebody is using it in that moment, you could say that you don't want to use it again. The problem is, it's hard to say if that smart object is going to be used later on. So you could say we have 5 guys running there. They all use a smart object. Maybe they should not use it. So one guy starts to go far away, but then the player shows up, and one guy is really far away. It should not be far. It should be with the other guys. There are so many cases that if you try to tweak one with some special, case scenario, then it won't work. The 90% of the cases could have problems. So what happens is, I think I really like what Rice did at that time, that he was more having a concept of contextual action. He was more in an area. So he could say, I have this wall, you can jump over it, you can place animation. It doesn't really matter which exact position. So if you had 3 guys, they could get just, 3 different objects. I think it was Paul worked on that. And that was really cool. And it was really also in the game code, it was using this off mesh grid directly. I think that was really powerful. We should go more into that direction, because what Austin did was also like a really link base. So we still have only one link, placed in that area. I think it would be much nicer to have something like Rice had in the past. And so at least basically the smart objects right now are like that, and it's not that easy to extend them. And I would not dare to do it because they're also a bit fragile as a system.
But the AI all know that they want to go through this smart object.
Yes.
They all know, or like apart from the first one who's using it, the other.
Yeah, if nothing happens, yes. If nothing else happens, you could predict that they all want to go there, but you don't know when. So it could be one guy pass it first, and you don't even notice that one guy is passing there. So the fact that the guy are really waiting for the other guys to jump over is not that much.
But they all know that the object is busy, so
Yes,
can't
they will
use
wait.
it. But then, as soon as that's now free, it's not like the other 4 guys will try and jump up on the same thing at once. There's some queue's been built up
Yes.
to say like, okay, I'm next, then
Yeah.
I'm next, and I'm next. So couldn't it be like the 4th guy in the queue is going to be waiting like
You
probably
can.
about 10 minutes
Yes.
to get up this
Yes,
thing?
you can.
He could then decide
Totally,
to
yes.
the way.
Yeah, that we could do that, something like that. There's also other problems, like for example, if you have a narrow corridor and one guy coming towards you, you're going in the same direction, you cannot pass through, you cannot get stuck. There's no way right now for the navigation system to handle that. He doesn't know. So, we need we could introduce, like, one thing I was always thinking of was kind of a blocker in the in GPS system where you say this street is blocked, and then you don't use that anymore for a while. Like you can say like this blocked for the next 10 seconds. So the Pathfinder will know, okay, I'm not gonna try to use this one, I will try something else. And if it fails at that point, at least from the behavior side, like, okay, this is the only path. If fails, I need to do something else because I cannot move there. And maybe you will eventually resolve that situation just because the behavior will choose something else.
Would you recommend to try to solve this on the navigation pathfinding level, or
which one?
Like 5 people going to a similar spot, or would you say it's maybe easier to solve it on the behavior level?
It would be better in the behavior level and the movement system level, maybe. So the movement system knows if somebody, it could know if you are in a, for example, execute, jump, and you need to wait because somebody is busy. Maybe that one you can say, okay, in that case, if you know there is in the queue more than a certain amount of people, you can specify in the request. You can say like, I want to move to this point, and if I need to find a jump where more than 5 people are in the queue, then I want to find another one, and then you can ask the movement system to regenerate. But basically, it needs to be on your request side, because imagine like if you really want to pass there, you need to be able to do it. It cannot be another system deciding for you to not make you jump there, even if you want. And make a really long tree. Yeah, this is the thing I was explaining. There are like 3 different type of links: the internal, the off mesh, and basically from the game side, you only see internal and off mesh. So if none of them is up, when you check if link type is, basically none of them means it's just going to another type. This is just to optimize the flags that we have. So this is the like a part that I put in the navigation documentation, and it's basically right now how we change the navigation system in the Pathfinder to update the multi-thread, and this can be a bit strange to look from outside, but basically the navigation system has different stages to update the system and allows user of the navigation system to calculate something and access the data in a multi-threaded environment, so to be safe there and be lock-free. So what happens is you first have one first step. Imagine you are just in a frame number n plus 1. So your previous frame, something happened. Then you are in this frame, and you wait for all navigation system user to complete their reading asynchronous task. This means you have lots of users that want to use your data, and they're doing some asynchronous operations. And in this case, you need to ask them to finish, because something else needs to happen. Is the new frame, and you tell them, I want you to finish your task. And I'm waiting until you finish, because I cannot do anything else otherwise. Most of the time, you're right to this point where all the tasks are already done, so it doesn't matter. But if there is something that is still executing, then you will basically go, in this case, to the Pathfinder navigation system user, that it will request to complete the running task. And this one will go to the Pathfinder, that it will try to finish his jobs. It will go to the job manager, that is our global scheduler for jobs, saying, I need to wait for that job. When the job finishes, it just tells the job manager, and then it eventually goes back to the navigation system. And you just say, okay, I'm done. Then you will say, complete your running task. So now, since you're done, you can tell directly the navigation system user another one. So you do for each user. Like we have the Pathfinder, and it can be, I don't know, something else that use navigation system. Right now we don't have it, but it could be. You go back, you finish to execute your wait code. Then next thing that you do the update for internal navigation system data. So it means like if you have something pending that needs to change navigation data, at this point you can do it, because nobody is reading anymore, so you can do your changes in the data. And what will happen is you wait for this job to finish, because something is changing already from the previous task. You get the result, and then you communicate everybody that something has changed on that particular time. So you can say like, hey, I changed this data. So if you are caching that data, if you are keeping track of that information, now it's not valid anymore. And then you spawn new jobs for the next thread. You say like, okay, I still have to change these values. Okay, right now I cannot do it. Just process the calculation, and next frame I will take care of. Then you update some internal subsystem. In this case, there is the off-mesh link, so the smart object or the custom links are updated here. Then you update navigation system user for synchronous writing operation. So here you say, I allow users to write data on me. For example, if you want to say that some game code increase the cost of some values, you can do it here. So here you can say, okay, now I'm gonna switch something because it allows me to do it. The navigation system allows me to do it. And you can do it, you can change stuff, but it needs to be synchronous. It means when that function executes, you cannot have stuff pending or running. If it is, it's a problem. Next step is I allow everybody to read my data and take all the time they need until the next frame. So what we call is update navigation system user for synchronous or asynchronous reading. So synchronous reading can happen all around the game code. You can call and request stuff. But asynchronous one needs to happen on this stage. So you cannot launch a job or a task that reads the navigation data and it not starting from this point because it's not safe. You can do it, but it's not safe. It's your problem. So right now you can do it, but ideally it would be nice if these updates could pass a special interface through the users that they will just be able to access this data only from specific updates and not from others. These are some useful navigation system CVAR. How much time do we have? It's 3:30. So there are islands concept. I mean, lots of stuff that we still didn't talk about and we're probably gonna skip. But the concept is there are lots of features on the navigation that allows you to have an easy or cheap request to where it's reachable and what is not, accessible and stuff like this. But it's not too much of interest for everybody. We have the Pathfinder. Maybe we can have a pause of 10 minutes, and then we can continue, or like maybe 5 something, 5-10 minutes. We can meet at 40, some 30. So the Pathfinder. So how does it work right now? It's been multi-threaded in the last months. So before, lots of stuff was contained into this class. That was the Pathfinder. The last path that was generated was there. It was only one request at a time. It was time sliced, but it was only one. The thing I changed, I basically created this pool of possible requests. So it's like if I can handle, 4 requests, and each of these requests is a little box where I can put all the information inside. And then every time I work a bit on one, I can say, okay, I work a bit on this one, I just change this data. And then in the meantime, I'm also working a bit on this other request and changing things in this box until it's finished. When it's finished, I tell to whoever asked that Pathfinder request that the path is ready and they can access it. So this is basically the new update of the Pathfinder. You have the dispatch result from your previous update. Then you clean up the requests so they're ready to be reused. Then you set up new valid path requests if they are. You can say, okay, I have this box. I already dispatched to you the path that you requested. Now I clean it up. I reset all the data. And now I can set up a new request, maybe for a new agent type, a new mesh. Then I can spawn the job to work on this. What happens is we have, right now the setup is we have 4 requests at a time. So on the same frame, basically 4 requests are handled. And they are still time sliced. So each of that can still use only 1 millisecond. So you would just basically have more requests, but in the same amount of time it's requested. If we keep the multi-threaded part, it's not a big deal to even increase a bit the amount of time that we give to these jobs. The only thing is we need to balance to not occupy too much the job system, because maybe other requests could want to use the job. Here you can see some CVAR that you can use, like the Pathfinder quota is the amount of milliseconds or seconds in this case that you can use for a specific evaluation. Pathfinder debug, it just shows you some data. Profile memory, it tells you how much memory it's using, and the Pathfinder MT, enable, disable if you want to use multi-threading for the Pathfinder, and the Pathfinder concurrent request is the amount of requests you can basically fulfill on one specific frame. What's good of this is like even if we cannot use the multi-threading, we can still configure and push it back as it was before. So we can say, okay, one request in the main thread, so we can still do the same. What we could do is that we could maybe use multiple requests right now in the main thread, because maybe since we are running on the server, so there is one problem that also Timur brought up. That is, since we don't know how much our server structure is going to be for Hunt, there could be some server structure don't really like multi-threaded code. So some server are actually faster if everything goes in main thread compared to being multi-threaded, because we could have one physical server, one machine that actually runs some virtual machine inside, and each virtual machine runs an instance of the game. And that means that already the operating system is switching between updating the different virtual machine to say like, now you update, now you update, now you update, and this can happen anytime that you don't control. So if it's somewhere when our thread is running, and now it gets removed, and then it needs to go back there on the processor. What could happen is that the stuff that he has in memory gets pulled off and needs to be loaded, and that load and unload, it takes more time than running just on the server in one thread. So this needs to be profiled. We don't know. It could be that it's not so bad. It could be that the gain is still better than having everything in the main thread. You can customize this totally. So this is the good part. It's not that complicated. You don't have to change the code. On the other hand, if we still do a single-player game, our licensees can use it and can benefit from that, and they can decide how much they want to use of each thread and how much time they want to use. So that is also pretty good. And we can also enable it for single player, but not for multiplayer. We can just decide what we want to do. Any question about the Pathfinder first? It's nothing like super fancy, just a star. So just going through the map and finding a nice path. What is cool is that now we use a lot of smart pointers. So the path is mostly, I try to remove all the cloning of the path. Because before it was duplicating a lot of paths and putting in memory and destroying it. Right now it's basically just keeping one version and then it's passing through the systems and everybody's using the same path. If they want to change it, then they can clone it, on their own. But I mean, at least it's a bit more contained.
One question actually about something I was talking right now with Oliver.
Okay.
3D navigation. The old 3D volumes are supported and they're still working?
No.
Don't work.
They are just not supported.
Not supported.
And don't work. Probably. Nobody really knows.
Okay.
I think this since Crysis 1, nobody uses that. So I doubt it still works. The navigation code, old navigation code may be still there. It's
the generation, the editor is still there.
Yeah, but the editor doesn't mean much.
Crysis 1, so that was
Yes, so anything he wants to use the code needs to support on their own. It's really, I would not recommend to do it, but because it's just something we don't have the code that uses that code. Because this is the other problem. It's not just that you get a path in the 3D, but you won't get it anyway from the Pathfinder, so you would have to use the old one. And then you would need to use that one. That means that there would gonna be like code there that is not executed. The code, you should use code pipes, you use the old behaviors. I mean, you can give it a try, but I have no idea.
You have an old Pathfinder.
It should still be there.
And how do you select that rather than depending on the navigation system?
It depends. Well, first it depends who use hand the request. So there is like from the system you can say get M&M Pathfinder, get Pathfinder. So that's the first one. You can send a request to one or the other one, but that I'm not sure how it works.
So the gold pipe, so basically.
No, but you could request it. Yeah, sure. That one does it automatically. Yes, so the stick and so if you use the really old behavior, the old gold pipes, then that one will still go. Actually, I'm not sure if we still go there because
that was the code that was using it.
Yes, but we changed it for at the beginning of Crysis 3 when we switched to
there was a new
M&M.
I think it was a new gold pipe.
No.
Before it was using the stick direct.
We used the stick as well for a while because there were other old. I think I'm not 100% sure, but I think we changed it. There were some codes say like if M&M active, we use this other Pathfinder. So we need to check what it is right now. It could be that if def is not there anymore, it's solid. But we could restore it. I'm not fully sure what is the status right now, to be honest. I think the idea is that even the licensee should have used the new code. So probably the gold pipe were starting to use the new code anyway, because nobody would support the 3D navigation and other stuff. So since nobody knew it and nobody wanted to support it, it was better to use the new code and leave the other code down.
M&M is source for walkable navigation, right? So
right now, yes, but nothing prevents you to extend it to like more because you have the voxelization of the word, so you don't do anything more.
Another one connecting with that. How is this to change the Pathfinder if I want to implement a different kind of algorithm?
So
maybe based on the wideness of the path of navigation, or I want more data from.
I would not change the Pathfinder. I would, in that case, if you want to have something like that, I would make a special Pathfinder that he wants to do a wide pathfinding because it needs to do much more stuff. If you want to have the flying is a bit different concept. That one could still be in the navigation data because the mesh could have some extra links that actually go somewhere else, similar to the off-grid links, and they would tell you like all these triangles are connected to a flying area, or you, for example, give for granted that all the triangles you would fly from, and then you have all the areas where you cannot fly or something like this.
Yeah, no, but it's like it's not super tied to the M&M, the Pathfinder. I mean, I could
Well,
extract that and, I don't know, next month a super awesome algorithm comes out. And
yeah, you could extend it. It's just a normalized star algorithm, but it's based on the navigation in M&M in the sense, at the end of the day, what it does its own calculation on a triangle.
yeah,
So you can extend that. I mean, it's not that so what I mean is like it's not extensible in the sense that yes, its own representation that is passed from the navigation system to the Pathfinder. It's not that yes, an abstract graph concept. You really manipulate the mesh directly, but you at that point, since you are changing, you could extend.
but they could potentially swap to another Pathfinder.
Yeah, you could. So that's not a big problem. Yeah, or you can, you can have a special part that is just pathing through the M&M until you get a specific node that allows you to fly. For example, if you have some only areas where you can start to fly, and then from there on you switch your new request to the other Pathfinder that you patch it up. It depends what you want to do, but then you also need a special smart path follower because the other problem is what's our path follower doesn't really support flying things really nicely. So we don't really have a follower that actually handles flying, paths. So for the helicopter in Crysis 3, it was a special behavior node, that it was handling the flying through some specific paths that were specified from the level designer. But we didn't have a generic solution for that, so you would need more stuff, is what I'm saying. But nothing prevents you to do it. So moment, this is what we were saying, like where the moment system is the core concept of how you move from in the world, and this is what we introduced in Crysis 3, and we basically are porting now in Ant. The concept is you send a movement request that it can be I want to walk to this point, and the movement system handles that. It passes this request to a movement planner that analyzes the path, and then it creates different blocks on the path, and then each block knows how you will need to move. In this case, if you want to fly, for example, you will have to say that this path has an area that is marked as flying area, and then in this case, the planner needs to say, okay, I have this section is flying, I will just add a flying block, and then the flying block is going to update a special path follower that you need to pass and say like, okay, to fly, I need to use these rules. What we have right now is we have these main two blocks that are the follow path and the use smart object. We have what you want. We have an arch stop, or we have a turn on the spot. Basically, it's a way to say I want to turn before I start to move, or I want to hard stop at this point, immediately stop, or I want to just follow a path. What I'm doing right now in this week, and I'll try to submit it before I leave, is having this special custom block. So everything that is implemented in the game side from the custom links, like the one from Rise or the one from Hunt, they can specify in the game code how you need to perform that special operation. So basically the jumps or the climbing is not tied anymore to the smart object, but it can be specified by the game code. And then, for example, you guys that are working on the puppet, you can implement how the puppet gets that request and handles the request from the block, and you can handle the block. So here, basically what happens, the movement system should handle your request. So you should be able to pass the request with the parameters you want. If you want to retry to pathfind, if it fails for 3 times, you need to ask it. Now there are some stuff hard coded because it was for the needs of Crysis 3, but we can extend that to allow whoever makes the behavior to be really explicit on that side. Or if you want to say, if I fail, I want to find another path and I want to block that area, this is where you should put it. The path is really simple. It uses a SINA path structure that right now is owned by somebody. The movement system doesn't know. The movement system only knows about movement actors. So basically, it's like if you register to use this service, you need to be a movement actor inside myself. So I have a representation of you that is an actor. And then you need to provide me some implementation of some basic functionalities. And this is only used for back compatibility from SDK reason and Crysis 3 reason. You have an adapter that I can tell you like, okay, if you want to use all the functionalities of the movement system, these are all the functions that I will call on you, and you will have to provide me something. If you don't want to use that functionality, then it's fine, and you can just give an empty implementation and only do whatever you want. So for example, there are some specific function to handle smart objects. It doesn't mean that you need really to implement. Maybe you have your own custom block and you don't even use a smart object, so you don't care about implementing that. The pipe user that before was the holder of the path and all this functionality provides directly to the movement system this adapter. So for SDK reason, you don't see any difference. It's already there. It works exactly like before, but actually internally, the movement system doesn't access anymore the pipe user or the eye actor. So there is a complete disconnection from what it was, the eye system. Now it's a kind of bit more in the direction of being an independent system.
If you don't provide your own implementation,
it will crash. No, you need to. So you cannot even pass a not something. It's a reference. You need to give him a reference to that. It needs to exist. It needs to be valid. It's up to you. So if you want to use, you need to respect the requirement. Of course, we can change in other ways if we need, but I mean, it's more to make people aware of what's happening and make people aware of what they are doing. We could provide an implementation, but that makes things a bit more shady in the back, and you don't never know, why things don't work. Yeah, this is more or less what I just explained to you. So this is the smart object. For example, this one to show you the back draw. The guy is basically Pathfinder through the world and is just jumping on a rock. And what happens is, you see, you have here the plan for this human that is registering the movement system, and he has a follow path, a use smart object block, and follow path. So you will see this square parenthesis in the block that is active at that moment. So in this case, you have, you already did the follow path. Now it's playing the smart object animation, so it's there. How to play the smart object? You don't care. It's that block that is taking care. So it's gonna request the animation system to be positioned exactly in one position where it needs to start the animation. Then it will have his animation update for the jump, and then it will give back the result saying, hey, you can now follow a new path. What is good is that these blocks can be specific. So you could say, when you have an animation block or a smart object block, I don't want you to cancel this path because I don't know how to handle it. So anytime you have an animation, this needs to be finished. If you get a new request or something, you cannot cancel this request. But maybe if you are in the follow path, you don't care too much. Like, I'm following this path, but if I get a new request, I want to adapt and I want to go to the other one. So each block can say if it's cancelable, and if you can insert a new path and stuff like this. So the planner can have all this information, and ideally the plan should be able also to patch an existing plan instead of just replacing it. You could say, okay, I have already this path. I don't want to completely cancel it, but I just want to patch it so the animation system can predict a bit more what I need to do. Maybe I will follow it for the next second, and then I will switch to the other one, something like that.
What would happen if the smart object action fails somehow?
So that one is the block can handle the failure in its own. So in our case, what we had this fallback for these, really important blocks that it would just teleport to the end. So let's say, like, it doesn't matter, this block needs to succeed all the time. Worst case scenario, you need to arrive to the end. Some other areas, for example, if the follow block would fail, that means there could be different versions. One, it could be that you cannot follow this path anymore, it doesn't have the path anymore, or it gets stuck. So what it would do, it would try, it was a bit hardcore, so we could extend that, but it would say, like, you could try 3 times to regenerate a path with your request. So it would say, like, cancel this request, I couldn't fulfill it, just give me another path. If you would get another, imagine like I'm just working on this table, then I fall down. It can be that here there is still another area that is walkable, and maybe there is a ramp here and I can still access it. So if the player push me down, if I get a new path, I can still get a valid path that I reach the end. So that is fine. And in our case, it would just try 3 times, because maybe you get the same path, because maybe you are just stuck. Somebody just throw you an object and you don't know, you're just stuck and you cannot move. And what would happen in that case, if you cannot handle that object in any way, you would just try 3 times, and then after 3 times you would say, like, dude, I cannot do anything. I fail to fulfill this plan. So that is the behavior knowing, okay, this move failed. So what do you want to do next? If you do the same thing, it will continue to fail, but you can react to that.
What happens if while it's executing the, let's say, the contextual action, or whatever it is, there's another command. You said it gets discarded. Does that mean it gets discarded completely and ignored, or does it get postponed?
It gets postponed right now, so it will just be in the queue and it will be executed as soon as you can. But this as well, you could say what you want. You could say, like, in the meantime, I postpone it, but in the meantime, give me still a path from the next position in which I am. So you use the moment of the jump to calculate that, and maybe it's faster later on. So, but the movement system can handle all these things, and this is why it's good. It's good because it's centralizing the request. You know exactly where the request come from because you can back and see who's calling the movement system. It's only one area. It's only one area responsible for moving the guy, and it's not like before with the gold pipes that each gold pipe could move the character, and you do not know who will win at that point. So it would be really hard to sync them up. Any other question?
Are you going to talk later about the implementation of the movement actor? Or
the movement actor is out of the scope right now, but we could go through if you want later, or we can, it's not really complicated. It's just like saying the movement actor need to send you some callbacks. So it will tell you, for example, okay, the movement system needs to tell the movement actor to find a path, to hold a path, and to give you a smart path follower or path follower that the movement actor want to use. Because imagine the movement actor represents a guy that is drunk. You don't want to really follow the path super straight. You maybe want to just see the guy that is moving around. So the actor needs to say, oh, I'm a drunk guy, and this is the way I follow a path. So, the movement system would say, okay, give me your path forward. Or it would say, give me the path that you hold. And I will take care of that, and then I will give it to you back what you need. So in this case, the movement system would say, I need to find a path. You know to who request because you are special. Maybe you are flying, so it's up to you to request not to the movements, the navigation system, but to the flying navigation system. But I don't know who you want to ask, or to the old Pathfinder or to the new Pathfinder. I don't know who you ask. Then I say, okay, when it's done, let me know. And you will say, okay, when you receive the path, you will tell the movement system, hey, I've got a path. This is the path. The movement system will pass it through the planner. It will just split into different blocks. Then whenever a new block happens to arrive there, it will just say, okay, now you follow this path. You give it back to the actor. The actor will hold the new path that is just a partial part of the old path. And then he will attach it to the path follower and say, okay, I know how I am done. I know that I need to pass this path to the path follower. And then I say, okay, now the path follower is ready. And the movement system is going to update the path follower. Saying, okay, now you can update that, you can update that. And tell me when you finish. And when the path follower finishes, it goes to the next block. That maybe is the smart object. And when he finishes, it gives back to the smart path follower, or the path follower, or the flying follower, whatever. So this is how it basically works.
The physical movement of the actor is done like in the old way, because it's like using this player movement controller stuff.
For SDK, yes. For hand, it's going to be a bit different. It's going to pass to the puppet. So then it's up to you through your adapter. The adapter will say set velocity, as this function that gets called an adapter. And when the movement system updates the path follower get the direction in which you want to move. That speed is passed through, that velocity is passed through the whatever it is. You don't know what it is from the movement system side, but you as a movement actor that you pass your own implementation, you know where you want to ask. So the pipe user will pass it through his own request, and it will go eventually to the old player movement controller. And for a hunt, right now he checks basically if he has a puppet component, and he will pass it to the puppet eventually. He will just give back, okay, this is the speed I want to go. The velocity, so just the speed. So, it's good because you can really customize as you want. If you use the code, it just works as before. Behaviors. So, behaviors is in the behavior 3 folder. This is the new modular behavior 3. When you look at the behavior 3 XML, right now, Mario is working on this editor that it will be in ANT first, and I guess it's going to be in SDK later on. Basically what it is you have this main block. So the behavior 3 block is just containing all the things that the behavior needs. You have variables that are like the previous one is the way you basically collect your knowledge about what's happening and how you can take decision over. It's like, do I know that there is an enemy, or is it mine cover, or something like this. Mine cover is not really a good example, but then we have the signal variables, that is what the system tells you. So it can be, or you've just seen a character, or you just enter a fire area, one guy throw a grenade at you, something like this. And this one is used to automatically switch some variable. So you could say like, okay, imagine I want to throw a grenade, and I don't want to throw a grenade for like, really often. I want to throw it only once. So as soon as I throw, I can send to myself a signal and say that signal immediately switch one variable. So maybe in the behavior I can say, okay, if once I threw a grenade, then I'm not doing it anymore, and I just not entering into that area anymore because I already have that knowledge. I don't have to check it back. Do you have timestamps that are used basically from the signal to say, okay, I'm sending a signal, you've seen a character, or you can check how much time has passed since you've seen that character, or since you didn't see the character. Then you have the root where the actual node the behavior tree is implemented. So this is to give you a bit of information. Like here, for example, we have some old Crisis 3 variables, what we used to in Crisis 3. So for example, you have some variable that explain which assignments you get, or if you want to execute some sequence, or if you are a sniper, for example. That is something you never change. So you can put it in the tree. You could also have better, like, let's say, implementation where the sniper would have his own tree, and it would be a bit more specific. But if it's really the same and has only a little flavor on top, then you can add a variable and add it. It depends what you want to do. Or some other stuff like go to mounted weapon. This is more stuff. You will find really strange examples here, and not take everything as a good example. But some stuff was due to the fact that we had to maintain some old behaviors. Like the mounted gun, for example, was just using the old Crisis 2 behavior. It was not really ideal, but we didn't have time to do it. So not everything that is in the Crisis 3 example is good. It's just like some is good, some not. So ask Mario all the time to check if something is cool or not. These are signal variables. For example, an enter cover, you will just switch when you get this. When you get the signal on enter cover, you can say that the variable in cover switch to true, and when you get on leave cover, the in cover variable is false. This allows you to create this kind of switch on the same variable. And let's say a better example, like on target enter close range, for example. You can say that the target is in close range or not if your own target is just coming close to you or going up. The timestamps, in this case, they are really cool because you can also specify if they're exclusive to another timestamp. So for example, in this case, the target spotted is exclusive to lost sight of target. So it cannot be that you spotted the target if you also lost sight of the target at the same time. So at least you can always request from the behavior tree saying, how much time since I lost sight of target? And how much time since I spotted the target, The idea is like to try to also put the name as soon as, like as close as possible to request English-like sentences. So when you read the tree, it's clear. Target spotted, for example, comes from all the old times. And this is why it doesn't sound so nice, but lost sight of target, for example, or received damage or being shot at, all the new things we did. And this is the tree. The tree is made by multiple different type of nodes that can both be created in the iSystem, in CRYENGINE, or anywhere in the code. This is really the power of the behavior tree compared to before, because you can make your own nodes everywhere. And the game code can specify exactly what they need to do in the tree. In this case, for example, you have some specific, execute Lua. This is a kind of a global thing that is in the iSystem. You could just execute some Lua script, or you could have, the set alertness is kind of really specific to the fact that we use the old perception system. The perception system could expose this node when it's there. If you delete the perception system, it could just not be there anymore. It could give you an error. So it'd say like, hey, you're using a node that is not supported anymore. And this behavior tree cannot run. So we always went on the approach of having really explicit error. So if something doesn't work, the behavior tree will not run. We just give you a big error message. It will just stop. The guy will not do anything. And this is because you need to be careful what you do. The silent handling of error is always really dangerous because things appear to work and they actually don't until you ship the game and it's bad and you're going to fix it anyway. One thing we have, some special notes, for example, for prototype, that is high bubble, so you have like this message on top or communication notes. Not everything is here. You need to go on the documentation. There's actually documentation for all the nodes. We already did it, so that is cool. We even have talks. Something we cannot complain about for once. And all the nodes are actually specifying also which one are the properties that are required and which one are optional. With the new basically behavior editor that Mario is working on, you will have everything by default from the editor. So it will just tell you what you need to pass, what you don't, and what is important, what not. It will expose things. Yeah, any questions so far?
Super, maybe it's a stupid one. The variables are only booleans?
Right now, yes. Because the concept was that we made this really super fast Boolean variable during Crisis 2 for the selection tree. And it was just really fast on evaluating because the other variables were too expensive. But right now what Mari is doing is introducing this blackboard concept that can take from schematic. So in theory, schematic could pass the variable every frame and say like, okay, this is now my new concept in the blackboard, and the behavior will read from that.
Okay.
Or other nodes can also.
but
We need to check. We need to profile and be careful to not pass too much, because at the end, if you do too much as well, like that is really impossible to fix it. So the concept of the Boolean one was really like, okay, we can even abuse a bit with that, and it's still gonna be alright.
No, it's nice.
This is why we use it.
I was thinking even on an integer to count things, or
yeah.
I don't know what up to which extent.
So what would have done at that time if we would really need that? We would have used Lua. We would have stored in Lua, and then we would have read from Lua. But as well, like Lua has never been a really big problem when we tried. Like UK as well extended to use Lua, and we thought it would have been really dangerous and slow, but at the end of the day, it was alright. It was not any big problem. So you can try to use whatever you want. In this case, probably the direction is the blackboard.
Yeah, I know.
So this is like a small real example we also use on the EigenDev conference. It's just to have the concept of how the tree looks. The tree is really a tree right now. So it just goes through and you execute some nodes, and it just goes to the different nodes. You execute some action, or some nodes that are just what the concept of decorator is. So it just gives more flavor to what's happening, or it just is a logical node, or a flow control node, that you can just have different things. Right now it's not important, but you can go through the code and see how they're implemented. The main concept is the nodes have just no concept of any sort. They're just a node. And what it means is they can tick, that's it. So they basically, when you tick, if the node has never been ticked before, you first initialize. We can see, I think, I will have something here. Basically, these are the main elements from a node that you need to implement. So you first load from XML, you can just pass some data. Then you have this initialize. So the first tick initialize, you execute some code. Then you updates until something happens, and you need to return what is your state. It can be running, failure, or success. And when you return something that is not running, it terminates, and you clean up the stuff, and it goes to the next. So this is just the only thing the node knows. They don't have any idea what they are. They don't have any concept of anything up. It's external. Just execute these 4 things, and that's it. So anything else that is added is wrong. That's it. Like there is no other concept that should be added to the node to keep track of any other concept. Because the thing is, the behavior tree manager knows that they are just a really simple concept. And you can put that inside whatever you want. But you should not put restriction on them, because they do not need that. This is the backdraw. So you have some information. This is not really new. I think there is some new stuff from the variables, and there is the timestamp here if you enable it, and there is something else with the blackboard I think right now. But anyway, you will always see on the left side the tree. You will see what is running, what is executing at the last, what is the last node that is really keep it out. Then you have the personal log that is. If you go here, you see these logs. So you have a node that is log, and then you have start log, success log, failure log, and there are all this information that you can pass through each node that they report what they do. And what we try to do was we try to keep track of the flow of what happened, not really like saying idle. Like this is really a bad example that we had. And we were just saying, okay, idle, whatever. But idle is also the first state, so it doesn't really matter much. But if you go here, for example, you see that you are from idle, then you are investigating a suspicious sound. And then, you have these things that are not super cool as example, because it's like comma, seek cover. But then you have other things that are really cool, that is like attempt to search for a cover from immediate thread. But this is what we ended up using much more than, because this was just at the beginning when we started to develop, and we also evolved the usage of the behavior tree. And what it really gave us most information was this type of comments. That is like, you see the flow of the behavior, how it's going on. And when you see something strange on the QA, for example, machine, you can just press / that is just giving you this, the backdraw view. And you just immediately see what they try to do and why they're doing something weird. Maybe it doesn't make sense. Most of the time, you see immediately what's going on wrong. Because you see the flow, the state maybe that they're just floating too much, or there is no reason to go into the suspicious sound because there was no suspicious sound or something like this. I can really understand what happens. This is just an example from the game code. I mean, from any code, when you create a node, like in this case, this is coming from a decorator, it just has an initialize and terminate implementing. And then at the end of the page, basically when you call the registration function, you just do register behavior 3 node, you pass the manager and the name, and then it exists. So you can do it from everywhere in the code. Yeah, any question for behavior still? One thing that we will look now is how the level designer can script AI agents, so how they can suggest them to do something. In this case, we start with the AI sequence. That was the first thing we started to implement. Basically, the level designer can script in a similar way as it was before, with the old flow graph. And they can say, for example, okay, I'm starting a sequence and I want that the guy moves to this type point position, and that's it. The difference is you can specify this if it's interruptible and if it needs to be resumed. Interruptible means, do you want that the guy can actually perform his behavior normally after you tell him what to do? If something happens, for example, if the player shows up, should he go into combat immediately or should he finish really what the level designer told him to do? The idea is basically to have this system that can describe what the level designer wants the agent to do. But what we ended up having, basically, were these two stages, was the interruptible and uninterruptible sequence. The uninterruptible one was the most dangerous one, because we ended up having this sequence that they were forcing the eye doing something, and then the events that were happening in the world were just lost. So we had this case, for example, I think it was in a level where the heavy was just passing through the wall, then it was just showing up to the player, and the player was already there, and the guy was perceiving the player while he was performing that sequence. So the behavior never knew that the guy was actually there, and he had to, perform something else after. So he was staying idle and just doing nothing. And we were like, how can we solve this? So at the end, the way we solved, so this is basically still for the sequence, the decision when execute a sequence belong to the behavior tree. The level designer should suggest what to do. So they can tell you, for example, in this case, I want him to enter through the wall. And this is what the level designer needs to be able to say. But there can be cases in which the behavior is still running and doing something special. It needs to finish. You cannot do it in that moment. So with the interruptible or uninterruptible sequence, whatever you do, however you implement them in the behavior, you can decide there are specific entry moments in which you can get suggestions. But anyway, the best thing that we came out with was the assignment. And this is what we wanted even to extend more the usage compared to the sequence. We didn't use it as much as we would like to. But basically for that case specific, we made this combat move assignment. And what would happen is the combat move is a special assignment saying, you tell the AI you would like him to move in that specific point, but he's still into his own normal behavior. So you can implement, for example, the combat move in the idle. So if nothing happens, you will just do the regular move to the position. But if it's in combat, he may want to be able to fight the player while he moves. So he still needs to pass through the wall in that case, but he still needs to shoot the player. And the good thing is these assignments are embedded into the behavior. So it's up to whoever makes the behavior to provide that functionalities and make it working in the systemic world. And these are high-level comments. So the level designer is much more free to say, I want him to defend this area. I want him to move to this point and fight. It doesn't have to say, oh yeah, I want to put this tag point here and say I want to move here and then I want to move there. Because there's a lot of micromanaging of things. In some cases, maybe you still need it, but most of the cases, this is like if you provide enough assignments, then it's already good. Of course, you need to provide the assignments that the level designer needs. Otherwise, you will just not give them enough, control of what they have to do. In our case, we had only few. We had defend area, we had, I think, defend position, combat move, and another one, I think.
There was some more specific to the character.
Yeah. But more or less was this. And what is good in this case, for example, you could also have assignments that are not really like commands. So like, for example, the last example that I put, we always use it, is jump on the tree while you move. We had this stalker that he was just going around and jump. And one thing that we wanted to experiment, and we didn't do at the end, but it was, sometimes, maybe in some specific levels where you have a lot of trees and stuff like this, maybe you want him to just use the trees more. And you want to tell him only maybe in some moments. Maybe when he's idle and he moves, you want him to jump around. But maybe when he's in combat, you don't want that. And the level designer can have this control. Or if something happens, imagine like they don't know where that the player even exists, then they're really relaxed and they can suggest them, give them some suggestions to the behavior and say, now perform more these things. It doesn't mean that they have the exact control what they do, because maybe the behavior needs to handle different things. But it's a good tweaking of the level and the behavior, so you give more depth to the experience. So this is what we always suggest to use more than the sequence. Of course, the sequence is an easy way to prototype things because you can just tell him fast what to do, but the assignment requires a bit more coding support, but it really is the one that gives you the best quality. Any question?
Are the assignments assignable also by behavior?
What do you mean?
By code.
So there is usually the way we provided them like a flow node, and they could say like now, like this, like assignment defender. You could say set, like pass some parameters to the different assignment. It depends what you need, and it depends how you want to pass it. And then you would just use this data and the behavior to.
So it cannot be like part of the decision of the.
It will be a part of the decision. The implementation is in the decision. So the level design can say defend this area. Maybe you cannot defend that area. You just don't do it.
Yeah, but this is more meant again for level designers to assign things. It's not like the behavior on its own deciding that I should do this assignment or not. So
no, because it's an interesting thing. So you basically say like, I have to go to that area to defend that, but meanwhile I have to fight this guy. So I interrupt somehow this assignment.
You can
fight the guy and then.
But that should be basically how you define.
It depends how you implement that defend area. You could implement the defend area that if you see the player and the player is escaping or then you want to chase it and for a while you interrupt, you do that. Because your information on the defend area is still being there. So in the way you belong to the tree, the decision making can happen that then you evaluate and say like, okay, now I don't have anything else to do. But I've been told to defend the area, so I need to go back there and still defend it. And this is why for example, we had this double implementation in the idle and in the combat. So what was happening was the idle could leave at any moment. Yes, a block on the behavior that say, I'm doing nothing, I'm just defending and maybe walk around. But when the combat triggers, it's not that I forget that I've been told to defend that area. I go into the combat. What does it mean? I don't know. I could just take off the gun all the time. That is not related to the assignment. I could scream, or I can go sometime. If I'm alone, I could still request some reinforcement. But in the meantime, when I go to the actual combat behavior, I may go in an area that says, okay, this is how I implement the defender, and this is how I do it. I can interrupt, I can do something specific, I can use some special communication lines. So I can say, I am defending this area, I need to have help to defend the area instead of using the global one. So it's really specific to what happens, and it's really much, yet a lot of flavor to the experience.
So how are the assignment actually implemented?
So
the behavior tree or
the behavior tree right now, what we had in the tree, you can see some. They were like the assignment were setting some variables. So in this case, there was, I think I cannot see it here. The combat move or position. So you had this knowledge in the. You were sending like a signal, I think, or it was maybe switching directly variable. I don't remember. And what you would say is like, okay, now you have this variable switch, and whenever you do your evaluation, you can check it out.
So these are, do you understand? I thought it was another.
No. It's in the same. No.
Running parallel with the.
It could be that you send a signal and you just keep track of the, for example, you could keep track of the timestamp when you last receive it, and maybe you receive 5 and you just want to use the last one. I mean, usually, you should not mess up too much with the flow, otherwise it gets complicated.
Right. So can you go back to the flow graph of the assignment?
Yeah.
So that assignment's defend area, that's just setting the defense area variable in the modular behavior tree?
And these values were set in Lua and then they were retrieved by Lua.
That is implemented by each assignment. You can specify. So basically, the information as well. It was just stored in Lua, the variables themselves. That was like just the way to implement it now. Now you can probably switch to the blackboard. But anyway, it's just a matter of like you receive that information. Now it's up to the implementation of the behavior to actually handle that information.
But that was, but then that's the thing. That was still carried out in the behavior tree.
Yeah.
You basically, this is how you define it. Like if there's nothing there, like it doesn't know how to react. So you need to explicitly go to the behavior and define, this is how I act if I have this assignment.
Imagine you have one guy that he cannot defend there because he's a loner, you know, or like he's a special character, a superhero that doesn't defend there. Then you can just not implement.
And the classic example is also like, you can define the priority. So you can have a behavior, like, okay, I'm defending this area or something, but then the player throws a grenade. And we just defined the grenade as like running away from it as like very high priority. There's very little things that I should be doing
when I have a
grenade. So basically, it's not like I forgot my assignment. Like I still want to
for a while.
Yeah. But right now I really want to move away from the grenade. So you go away, so you switch to the behavior. As soon as that is done, then you reevaluate the situation. Okay, I have to move this far. Now, okay, my decision is still to defend that area. So I need to know, I need to just go back and start defending again. So.
This assignment nodes defined also in XML or something, or
this needs to be defined from you. Like there are no XML.
But I mean, so that like the defend area goes to the behavior tree.
You need to make a flow graph. No, you need to make it right now. There is no automatic creation.
According in the game code. Or?
It depends.
Like defend, send
the game code is never
defend area, set it to true, something like that.
Yeah, but this is what you support. So it's not the exact code. It is like you expose what you support. So if you support.
Yeah, I mean not a hard code, but it's let's say it's like refers to the React code.
Yeah, it refers to the code.
Specific values in the XML.
Not in the
variable names or.
The variable names depends on what you expose from. What you expose as a node.
You have to think of it as part of the implementation of the behavior. Yeah. The behavior, it's game side defined, and
so it's what you have is what you support basically. But you need to make in the code. You need to make the exact flow graph node to expose that functionality. Now you need to make your implementation of the behavior. Yeah. So these are just like global, overview of the behavior, the best practice. Keep the context. Try to keep the context of what's happening in the behavior tree. So if you have a behavior tree that is one guy that can behave in a certain way if he's in the car or if he's not in the car, don't do the same behavior with the check. If he's in the car, he does this, or if he's not in the car, do that. You should just be in two different areas of the behavior. You should know when he wants to enter into the car, that he's entering into the car and then going in a specific part of the behavior where he's in the car. It cannot be that he doesn't know. Behavior always should know what he's doing and why he's doing something. So be explicit, try to be explicit in what you say. So if the guy is hiding because he's trying to protect one guy, try to design the behavior to be able to say that line. To say, I'm just here hiding because I want to protect you so you can go on. It's like really explicit lines, but the character and the player will understand what the character is doing. Keep always decision making in the behavior tree because this is what we always found to be easier to track and easier to solve problems later on. And be specific. So as much as you can add new behaviors for specific events that you need to handle. Just not try to make a generic behavior that handles 1 million things and then maybe some other system pick up some variables and say the right line in the right moment, because most of the time things grows up in a really hard way and you will eventually say a wrong thing in the wrong moment, let's say. So it would just be random shit happening and it's never too cool. And again, you can trust us or not, but the proof is in the pudding. When you will hit your head against the wall because some problems cannot be solved for some decision making, is when you realize why some of the stuff we are saying are like this. But you should also experiment on yourself. Like there are things that it's not so easy to see, and when you just hit the wall, then you understand them. It's really hard for us sometimes to explain why we did things in a certain way, and yeah, unfortunately, it's just hard. Readability. This is what we always consider as a really important part of the behaviors. Never forget about that and do it at the last moment, because then it's bad. We have the communication system here. It handles all the communication, so you can create different lines that the behavior can say at a specific moment. And some parts is actually in CRYENGINE. So you have a little part in CRYENGINE, a little part in the AI system. In CryEngine, you have the exact implementation. So who actually tells the sound system to play a sound? So what happens is that this part is the one that should change if you have a multiplayer game, and this is what we did for Rise as well. We had this implementation here that it was basically implementing the game side for Rise, and it was basically keeping track if it was on the server side or on the client side, and it was really playing the sound or just getting the request from the server. This is more or less how it's structured. Basically, you have the communication manager. Usually what we did was the behavior tree communicate node that it was triggering a communication. So you could say, in this case, communicate player scene. That would have gone through this request, this play communication. It would go to the communication manager. The communication manager would have basically passed through the communication player saying, just pick up a variation for this line that is player scene and then play it. And the communication player, there is only one for all the actor. It would see this request and it would be like, okay, it's for this entity ID, I need to play this sound. And it would just access the communication handler for the entity ID. And it would just say, okay, now you play this voice or you play this sound. The communication in theory can also handle animation. It could also play animation. But the way we experimented more was a bit to keep track of more the audio, and the animation would have been separated, maybe not parallel in the behavior tree, because it would be more clear compared to have everything in the communication system. It depends. You need to experiment a bit and see what you want to do. And then you have always a queue of sounds that are playing, so you know exactly what is playing. The communication manager can have a different setup for channels, and we will see later. This is more code side. The entities have lots of proxies. Just to give you an idea, the iProxy is not used since a long time. There's no anymore an iProxy in the proxy list. What actually is where the iProxy is, it's actually handled by the iObject manager in the iSystem. So the entity will say, I'm this entity, I would like to get the iProxy that is in the iSystem. It will go through the iObject, and the iObject will have a request get proxy. And the get proxy will return an AI actor proxy. And this one contains the communication handler. So this one contains the communication handler pointer, that the implementation depends who provides that. In this case, it's in CryEngine, and it will just handle the request. It's a bit tricky, but you can simplify much simpler. The important thing is you provide this communication handler implementation to the communication system, and that's it. Then it doesn't matter. We still need to be a bit extended to replicate what we did for Rise. I think ideally we should do the same thing as we did with the movement system right now. We should have an adapter for the SDK to keep track of what the pipe user is doing, and then we should have the game code to register as the Rise entities we're doing, and it would be the best. So these are some of the functionality, for example, for the communication handler, the play sound, play voice, stop voice. So you could just tell them explicitly, I want to play this sound, I stop the sound. What is good with Rise as well was that this was happening only on the client side, so we didn't care too much. And some part was happening through Mannequin, so Mannequin was syncing up the animation and the specific request from the, for example, if you were running the type of breathing and stuff like this, and the behavior could request some special voice that was still happening through the server and then send it back to the client. But then what it was good for us was that all the sounds were on the client side. So we didn't have to sync up some sounds that actually were only requested on the server, and we didn't know how they were fitting into the request of the communication handler, because we have these files that actually configure the communication system and allow you to tell not only that you want to play a voice, but also where you want to play this voice, in which channel. So imagine if you have different priorities in your own behavior, there are things that are more important to say than others. So if you breathe, and you want really to say something, you will still say something. Probably you would say it, a bit with fatigue and something like this, but you will still say it. And it's up to us. We have this channel config. We can say what is global, what it doesn't have, which type of post each channel has, which type of priority it has, if it needs, for example, imagine you want to talk on the radio. You don't want to have this radio happening all the time. So maybe you want to say, okay, from the behavior side, I could request a lot of playing radio voice, but maybe I want to hear it once every 8 seconds or every 10 seconds. So you can play it on the channel that is the radio, and the mean silence is 8 seconds, so it means like this needs to at least shut up for 8 seconds, and you cannot continue to talk all the time. But then you have stuff, for example, like the injury, pain, or the choking that needs to happen in that moment. If you're talking and somebody in the player just hold you and you start to choke you, you need to play the sound of the choke. You cannot continue to say that voice. So everything under that priority is to be cancelled, and the silence doesn't care too much. It's not important. Ignore the actor silence. So it means like I don't care if that actor should shut up right now. I need to choke. I need to play that sound, or I need to die. The death needs to cancel everything. So you can configure all your channels here. It's completely game independent. You can just create this one in the XML file and just specific for your game. Then you have other communication. This is for Wise. I just made the port to Wise, and we had to basically switch this prefix to say the sound designer can create a sound to play a voice and want to stop it. Most of the time, the stop is not really going to be anything special. It's just going to be a harsh stop, but they have to implement it this way. In some cases, you could have a specific stop sound that you could also specify. For example, you can say that you don't want to stop with the harsh stop of the sound, but you want to say like or something like this, and you have a special sound that cancels it. You can specify that. So in this case, you have the prefix for the trigger. So this is to keep compatibility with the old stuff. You will still say, for example, communicate player scene, but under the hood to keep their compatibility with their new naming convention, you will always say play underscore player scene, play underscore or stop underscore player scene. So they will have this knowledge. Then there are some special parameters that can be set. That is the character and the character type. For Crisis 3, we had this concept of having the big guy or the small guy, the one with the helmet and stuff like this. And this can help the guys in Wise to trigger these values. So right now, probably these are set up just because we asked them to use it in the SDK just as a reference. It could be anything. It could be any parameter that you want to pass. And we could extend this to be a general mapping of parameters and values and possible values, so we can just have it directly defined into the XML and not anywhere else. And then we have variables. So we could say that some communication line are triggered only if some variables conditions are actually matched. So we can say that when I see player scene, it can be that I want to see something different if the player is above me or below me. Or I don't want to just see I saw the player. I want to say, oh, it's just down there, or it's up on the window, or it's up there. And I can basically create these variables that are managed directly from the communication system, and they can pass this variation in the system related to how the game plays. So in this case, you have this example, like here, you have this variation. So you have suppressing fire to protect others' first contact. And this one, you have a condition. This variation only is chosen if the target is above, for example. And this is just passive. The name is really explained.
Oh no. Previously, it was like said that the logic should be kept in the behavior tree and being explicit.
Yeah.
So then, would you now suggest that actually even this stuff should be done in the behavior tree?
No. So this is more like you can have the same behavior, but you can have some flavor on top of things. Like you can have something that is not really important for the behavior concept. But imagine like you want to say player scene, and it's different from the flow of the game when it's under a canyon, or somewhere else. Then you can make a variation for the specific level that says, if the player is under the canyon, when I see it, just mention the canyon. So it looks smarter. The guy understood that he saw it under that particular object, But from the behavior side, it doesn't have any really impact. If something has impact on the behavior, or it makes the decision making different, then it should be on the behavior. This is more like really to give a flavor on top. So you can say, I'm alone, and you have one guy that is really a crying baby, and you want to have a special variation only for him, then you can add it here. If it's something that if he's alone, he needs to choose to say something because maybe it's a special level, then it needs to be on the behavior side. It depends what you need to do, but this is just for taste.
Where do these variables come from then?
You decide, you specify. As soon as you expose them somewhere, you can expose them here, you can just add them a list here. Yeah. And then there is a special flow node where you can set them up. For example, you can say, right now this is a really simple implementation, but level designer could say, my level is called like this, and you can add this variable like called level is swamp, and then the level designer can set it up at the beginning. And we could use it if we want.
But right now the variables in the modular behavior tree, they're separate.
They're separate, yes. This is a specific one for the communication.
It's using the same system, but it's separate.
It's just basically there is an instance of this variable specific for the communication. So internally are the same, right? The same implementation.
But could you like use a variable in the behavior tree?
We could extend them to use it. Right now you can't with the implementation there is, but nothing would prevent you from doing it. It's just that we try to keep it separated so we really pass on the information we want. So from the behavior tree you could say set this variable for communication. You could have a special node that when you enter a specific kind of behavior you set that variable or not, that you can do it. And then I think it would be a bit nicer because you keep the two systems separated. And this is like how, as we create a communication, you just have the name of the communication, which type of finish, if it's blocking or not. We don't use this too much anymore, but the variation is just the actual sound. In our case, is basically, this is really the one that is implemented in WISE. So it won't be play com.det, but it would be play underscore AI underscore MPC underscore det. So they really have the different entry for the different variation. And for us, we just say, communicate target spotted while searching. For us, we just say that in the behavior or in the flow graph, whatever it is.
You trigger these communications in the behavior tree.
We use it only from the behavior tree, or in RYSE we use it from the mannequin as well. So because there is stuff that if you want to keep it track in the channels, then you need to pass the communication system. Otherwise, you have no way to stop sounds, or something like this. But maybe there's stuff that you still want to happen even when you're talking. So if you have like some sound, of jiggling stuff or metal things, you can either implement it directly to the sound system in mannequin, or if for some reason, in some cases, you want to stop them through the communication system, then you can pass them through.
Just a little question on the voices or voice names. Is this actually something that's similar to the audio signals, or is this literally only sound names?
It's not. Before it was different, but now they're just the signal from WISE. So basically, you need to write here whatever it's in WISE inside the human character, but without the play underscore. So the one that you specify the configuration is what you keep off.
And basically, that will define moods and themes and whatever.
You could influence the mood also from the behavior tree, but this is independent from. So if the mood is influencing this audio, yes, then it passes through the
but
system.
you wouldn't be putting it in here. You just
say the name, the signal.
Okay.
That is up to the sound designer. Even if they want to mix it in a different way, they know that it's a voice and they know how it's done, so they can take care of that. Word interaction. This is basically what I wanted just to show you is more the smart object and the tactical point system. So it's now how you really interact with the word. First, tactical point system. This is just a way to basically request things in the word. You can say it's a query system basically, and it uses English-like sentences or queries. You can request a position, for example, that fulfills specific requirements. The queries right now are written in Lua, and you can find the queries into this folder. So one example of the query, for example, it can be that you want to know which one is a position around the puppet in a grid that is visible from the target. This is taken from Crytek, just a little example. And you can pass condition and weights. So what you see the difference here is you have three phases, that is the generation, the condition, and the weights. The generation phase always happens in the main thread in one block. So if the generation of these points is really expensive, it's really expensive right now. So we don't have any way to make it faster. Conditions and weight instead are time slice. So you can say, okay, I want to update now the conditions. And the way it happens is you have a way to define this condition in code and saying if conditions, the evaluation of the code is cheap or expensive. So the system will try to evaluate first the cheaper one. Because if the cheaper one cuts enough points, then the expensive one is going to be applied to less points. It's going to be faster. And then the weights are just, applied to the points that are, fulfilling all the conditions, and you just use to order these points and get the point that is the best one. They just give it to you. The first one, basically. The structure is just, all these points are stored in a vector, but the way that it's inserted, it basically uses this vector as a heap, so you always have the cheaper one on top, and this insert just happens, there on top. The generation of split, as I said, this is the most expensive part. So this is why right now we have really kind of cheap way of generating point, and we don't have a really expensive one. But one idea as well that what UK also started to do, and they wanted to do more, was to time slice also the generation to say, okay, you need to generate this point, but you can use only 1 millisecond for the generation, so it's going to be a bit cheaper. And maybe we could multi-thread this if we need, but right now it's not a big deal. It is expensive, so for some cases it can be slow. But what we did a lot in Crysis 3, for example, we just used some little tricks where the first queries that we were doing was always really cheap to get. And when they were doing that, movement, for example, if you had to hide, the first cover, it didn't matter really much which condition you had. It was just, give me a cover where I can run to. And it just gives the impression to the player that you are reacting. And then while you're running, you can ask a new query and get a new result a little bit better, and you can adapt or something like this. Or you can usually get an expensive query when you are hiding in cover. So even if you're doing nothing, you can still, react if the player shows up. But in the meantime, it doesn't look so weird if you're just waiting there for 1 second or something. These are the smart objects that is similar concept to what we will use in Hunt as a contextual. It doesn't matter too much. Now just try to abstract, but this is more a bit of detail for the smart object as well. So this is what you see in the screen. Just a jump. It tells you that it's 1.5 meters. Usually the helper is really made for that particular smart object. So if it's 1.5 meters, it's 1.5 meters. You cannot change it. It's not. That's gonna be a jump of 2 meters. For having a jump of 2 meters, you need a new smart object, like you were saying. The idea is to have some elements in the world that can trigger something if some condition occurs. So the problem is, this is really a general idea of what it should happen, and they have several uses in the past. So they was used for navigation, to interact with objects that could trigger mini behavior, or they could trigger animation, or they were used in the interest system during Crysis 2. They were used for a lot of things, and some stuff was not too good. And this is why we at the end, during Crysis 3, we decided to use only for navigation purpose and to really nail it down what they were good at. And the thing that were creating more problems, we decided to not use it, even if some stuff could have been interesting to expand a bit more. So right now, when you bring a new smart object, you have this template selection, you have lots of stuff there, the bag, environment, idle, angles, basic, custom, navigation, time-based. That this means the way this object is triggered is based on the angle that you have with the object, or from custom properties that you just have a huge amount of properties, or navigation, or from time that you need to be close. It's a bit complicated. What we use is only navigation right now. So just to expand on that, just try to not use crazy way, because the support needs to be done on the behavior, and it's going to be really hard. If you want to do something, for example, I want to go to Boris and shoot him, and while I'm walking, there is a bottle here, and I'm really interested in the bottle. I'm just going there, and then oh wow, I have a bottle, and I'm stopping my combat behavior because somebody else just telling me to do it is really weird. And you have really no way to easily prevent that. Then you will have to add something on your known behavior that says like, yeah, but in this specific case, don't use it, But yeah, I actually want to use only this type, and it's going to be really complicated. So this is a navigation one. So this is a smart object editor that you will see. You can create some condition. This is cool. This is what we should maybe try to abstract a bit even in the Hunt ones, because this one was nice to have this concept of pre-state and post-state. So you would say, I need to fulfill this requirement before using the smart object, for example. And there were this case that we had in Crysis 3 that it was, when I was in search, I was in a special state. And when I had to enter into a door, instead of just going into the door and normally like doing this, I would just wait in the door and just jump in and look at the side. So it would feel a bit more reactive. Was not used as much as we wanted in Crysis 3 as well, but the idea was to expand on that. And we could use any system to do that. It doesn't really matter which one. But here you have some cost, multiplier. So this is the cost that you can add in navigation to say this is more expensive or less expensive. And you have some state in which you can say, for example, okay, I have this user that you want to use this smart object, and the only class that I allow is the human. So I need to specify this class to that object to allow this entity to use this smart object. On the other side, the object has these parameters. So this class is this jump, and when is in the first state, is not busy. Then the entrance is N1, start 1, this other stuff. When the action triggers, as soon as the action triggers, the user doesn't get modified. But the object gets modified and say it's busy, so nobody else can use it at that moment. As soon as one guy starts to use the smart object, say, okay, now this is busy. And that's why the other guys are in waiting list. Then you do a one-shot animation. In this case, you say, like, okay, I want just to place animation to mannequin. You say, I want to play the jump. And as soon as this is finished, you reset the state. So you say, like, okay, now this state, this object is again not busy. So minus means not in the state. You can have some parameters to the exact positioning, but this other stuff. Here you have a name and the location where it is in the plugin.
Where do you actually set the animation? That's one thing I've never actually figured out.
Here, it's just a string.
it's the action name, is the animation.
It's the animation. It's the fragment. Right.
Oh, okay.
Yeah. But in theory, this was supporting multiple styles. Supporting high action in the past, was supporting different things. What we only used from Crysis 3 on was the one-shot animation, because the other things also wants to control too much. So to be able to support all the high action for this, we should embed that in a way in which the behavior knows, more like maybe assignments. So it could be like, if I trigger this, it could be an assignment that gets triggered. It's not that simple. It needs to some work. That's why it needs to be somebody dedicated and extended properly this functionality.
Where does the actual, so like you've just created this smart object, 250 or whatever, and where does that actually live?
So these are all the rules. So these ones are just rules.
Yeah.
So the smart object itself is not this. The smart object itself is just an object that runs these properties that are executing.
Yeah, but so where's this rule saved? Where's it written to?
It's a libs smart objects, I think.
Yeah,
So it's in the libs or
objects.
something like that. I'm not sure if it's in the root folder. There is also another file. Things smart objects, but there could be some extra.
Just the only file inside libs.
Yeah, but there is another folder, is smart object, where you have the template structure.
Oh, yeah.
Which you have that one, and actually their rules set up. There is some weird thing. There are some structure, but yeah, it's in libs. This is where it lives. So they are really game specific as well. So the concept was smart objects are game specific. When you grade them, the rules are related to your game, and that's why they are in data to libs, because it makes sense. So it's not engine specific. I think, use them for navigation only. For right now, they're just used for that, and we would suggest you do that. They could be, investigated to something else, but I would say I would prefer to have something like the external links and having some external system that we can query. For example, if the model is interesting for me, I would be in the behavior. I should be in a state in which I'm interested into evaluating things. For example, we had this case in Crysis 3 in which we were thinking to have a search in which, for example, there could be some air vents, and you could look into the air vents. And we say, like, in that state, what it would be good is you could request saying, is there any air vent around me from the tactical point system? I would go to there, and then I would say, play the animation to look into the air vent. What we would need is to have a way in the behavior to say, interact with this specific object and play this animation, similar to what the smart object were doing, but in a moment in which the behavior is under control. So the behavior knows that is investigating into a specific object and is not doing random shit that it doesn't know how to end up.
You have to do that through level markup, though, wouldn't you, to actually identify what is an event in the level?
What do you mean?
Well, you said if you want him to walk up to air vents and have a look, but you'd have to actually do some kind of level markup.
You need to mark up that to be something. In this case, it could be an air vent, and then I will need to be able to understand that it's an air vent and that I can go there.
Would that be marked up as a smart object?
It depends. There is just not a system. It could be multiple things. It could be a tag in the entity point. It could be anything. Like, depends how we implement that. If we want to use exactly a smart object system, then we will have to have a way, like a special rule that is a proximity rule that is triggered only when you are in a specific mode that the behavior ends up. It's a bit tricky right now. And it's a bit hard to be sure that you do it properly without breaking it. This is why we would suggest you to say, okay, we should continue to do that, and I'm pretty sure Mario is going to investigate in the future to do something like that with also what the game designer are requesting, because you will have other requests to do.
So smart objects right now, I mean, but they shouldn't interfere with decision making of the logic.
That's what we need to prevent. Exactly.
But they do right now.
In the past, so yes, the sense like in the past.
In the past they used to, but now with the modular behavior tree, if I have a
now you don't care because you're not even an AI object, so you
exactly. So
yes. Right now you're safe. Yes,
yeah,
yes. But if we would like to extend them to be used in a certain way, then we need to extend it properly. Is what I'm saying. Yeah. So right now there is no really big danger for Hunt, at least. But if for any Crysis 2 supporting game, yes, the interest system could just move you to look into a car while you are, moving around and you don't want.
Is it possible to group smart objects? To build a group, like for example, if you have 10 bottles, like 10 smart objects, and one is used to block everyone.
You can say basically in the rule, you can say how this is happening. So maybe one of your state partner is saying that it's not used. And if in that case, if it's a proximity one, that one will not be triggered. It will be triggered with another bottle that is free.
But would you then, in that state, would you just not ever set the state to be like minus busy on completion? So once it's set, now it's busy, just never
reset, for example. You can say like that is drink, then it's empty at that point, and it's not full anymore.
Those tags are generic, so in this case you're using busy, that's kind of the standard one, but you can say the bottle is empty, so basically the others will not try.
The only big problem is that since these are so general and they live together, then empty, everybody would have the empty state. So it could be that they would, man, the human is empty. And say, what does it mean, But, this is why it's a bit tricky, because you don't have a state specific for one object, where you have just a global state that you need to set up. So it will pollute a lot these things, I mean, there's, downside, but it was also really powerful, so.
Does M&M consider moving smart objects for navigation?
So the thing is, if you move a smart object, then it will be the navigation system will be notified. It will be. Right now, the smart object should not move because they don't communicate exactly. So it should be extended in a way in which, as I showed before, the smart object system should be a user of the navigation system. It should queue the addition and removal of the link instead of automatically edit and remove it, because right now you automatically add or remove the links. This is really dangerous. But it's alright because it happens only in the editor right now. And this is one prerequisite we had in Crysis 3, we should not move the smart object runtime. But there's nothing in the code exactly preventing that. So if you would do like the hunt smart object do, because they can move, they can be changed at runtime. But they will just queue the request. So it's like, okay, I want to change right now, and don't do it immediately if you can't. But next frame I would like to have this change, and then it's alright. You could introduce a way of saying, okay, even if it's not changed, this is not really valid anymore, so you can communicate to the Pathfinder immediately that one is going to be changed later on and stuff like this. But we need to extend it as much as we need. So yeah, the interaction, as I said, must come from the PO3. This is the safest way.